Welcome back, boys. So this is part 2 of graphing f of x equals a x squared. So you should know by now the characteristics of a quadratic function, which is x squared. So hopefully you can distinguish a vertex, an axis of symmetry, zeros, which are roots, solutions and all that. So pay very close attention to this video, and I will give you your assignment at the very end. So let's begin. So I'm always going to refer to this parent function. So the parent function, as I said in the first part of this lesson, is right here. So it's f of x equals x squared, where a is 1 and b and c are equal to 0 because they're not there. And these right here are the points that will always be, that will make up your parent function. Okay, now some of you might be a little confused as to where I'm getting these points, and I'll show you in a second. So also with the parent function, you have your vertex, which is right here. And then you have your axis of symmetry, which I think some of you are getting yourself confused. And it is an equation, and it's the x value of your vertex. So this is what makes up the parent function. Now, here is your standard table of values for a parent function. If you remember, when we graphed way back when, I always used these x values. You always want to use 0. And you always want to use a variety of negatives and positives. So these are all consecutive numbers. Now, these are standard ones. You don't always have to do them. But if I chose 1 and 2, then you want the symmetry that these quadratics create. So you would want to have the opposite values of -1, -2. So again, you can pick any values, but make sure you have their opposites as well. So let me show you how I certainly got these numbers. So if you have f of x equals x squared. This is your x of -2. So I'm going to plug it in right here. And again, we did this in chapter 3. So if I were to plug in -2 squared, that would equal 4. So there is where I got the 4. Then I will do -1. So you have -1 squared. That would give you 1. Oh, look, there's your 1. Then you do f of 0. And you plug in 0. So all this is you're plugging in your values and you get 0. Okay, now if I repeat this and I do +1 squared, you're still going to get 1. So what I want you to understand is these values will match these values due to symmetry. So technically you could skip the work for these ones because you should have those correct. Now, should you verify that they are the same? Yes, of course, because, we always make mistakes. So this is what you always need to refer to. So you need to refer to your vertex and axis of symmetry. This is your table of values, and this is what your graph should look like. Okay, so you might need to use this video, have this slide up whenever you're doing your homework. Okay, so I do have some other characteristics of this parent function. Okay, so a, which I've told you is 1, is not going to be 1 anymore. So here's our first core concept. So as you can see, if you look at these graphs, you have this blue line is when a is 1. So there's your parent function. But then you have this red one, which is a little bit wider, and you have the green one, which is, skinnier. Well, what it's saying is that if a is between 0 and 1, it's going to be a vertical shrink, and it's going to be this red one. So it's going to open up wider. But down here, if a is going to be bigger than 1, then it's going to be a vertical stretch, which is the green one. Okay, so pretty much here is is my take on it. And also notice all of these are going up. So when A is greater than 0, so pretty much when A is positive, you are having a open parabola, okay? And then you have a vertical shrink of A when A is between 0 and 1. So pretty much when it is a fraction, okay? So that would be it opens wider, so that would be the red one. And then a vertical stretch of when A is greater than 1, that would be your green one because it stretched it, okay? So again, you might need to refer back to this when you do your homework. Okay, so let's do an example. So if you look at this example, we're going to do when A is greater than 0. Okay, so it's going to be an open parabola because A is positive. And here is our graph. Well, here's our function. So it's g of x equals 2x squared. So the only thing I changed was I added the 2 instead of a 1. Okay, so you're going to have to graph all this and then compare the graph to its parent graph of x squared. So first step, make your table of values. So notice again, -2, -1, 0, 1, 2. So let's plug these in. So we have g of -2. So 2 times -2 squared. Now you need to remember your PEMDAS rules. So if we do this, we do 2 times the -2 squared is 4. Looks like you would get an 8. Then we'll do g of -1, which would be 2 times -1 squared, which PEMDAS says be 2 times 1, which is 2. Now 0 is extremely easy. It's this 0. And let's just verify that the other ones are correct. We'll just do one of them. So if I do g of 1, that would be 2 times 1 squared, which is still 2 times 1, which is still 2. So then coincidentally, the last one's 8. So notice that symmetry, okay? The ends match, and then the inner ones match, and then you have your vertex. So this right here is going to be your vertex. So we have our table of values. We need to plot those points. So there they are. Now, obviously, you should see symmetry. If you do not, then you made a mistake. Draw your curve, and it's not a V, it's a U. Don't forget, parabolas are U-shaped. And then we're going to have to compare the graph to its parent function. So this is all we did was we did the table of values, we plotted our points, and we drew our parabola. Now, we need to compare them. So this blue one right here is the blue one that we just did. So I'll go back to that one. So this right here is your parent function. These values are from the first slide you saw. And here's the parent function. This is the red one. I'm always going to do it in red. So now I'm going to do these on the same graph. This is the problem you just did. And here are the points on your blue graph. So if you notice, it's in the inside of your red one. So now you need to compare it. Well, if you look at this, your vertex is the same. You have the same axis of symmetry, and it opens up. So the only difference is that it either shrunk or it stretched. So here is what I would like you to write. So both graphs open up, and they have the same vertex, 0, 0, and the same axis of symmetry. Give me the equation of x equals 0. Now here's the difference. The graph of g of x is narrower. As you can see, it's in the inside because it is a vertical stretch of a factor of 2 of the graph f of x. And obviously, there's your a of 2. So since that was bigger than 1, it had a vertical stretch. Okay, so for your homework, this is what you're doing, is you're going to give me words and a graph labeled as your answers. Okay, so let's do another one. So now look at this one. A is going to be still greater than 0, okay, but it's going to be a fraction. And same idea is we're going to graph it, and then we're going to compare it to its parent graph. So here we go, table of values again, same values. Now I'll show you how to do this. So here we go. So we have h of -2 equals, we've got 1/2 times -2 squared. PEMDAS says -2 squared is 4. Half of 4 is 2. Then let's do -1. 1/2 times -1 squared. That'd be 1/2 times 1. Now, normally I'm not going to give you decimals. However, this decimal is just obviously a half. So I'm going to put 0.5. Now, obviously, this is going to be 0, and I'm not going to do the work for the rest of them because I know that I was right. And by symmetry, they're going to be the same as the first two. So now I'm going to plot my points. And again, I know I'm not going to give you decimals on the homework, but there you go. As you can see, you have that symmetry. Draw your curve, and there you go. Now we're going to take this and we're going to graph it on the same grid with the parent graph. So again, this is our parent graph. This is the red one. It's always going to be in red. Now the blue one is what you just did. So here you go. These are the numbers we got. And if we plot them, notice it's wider, but you still have the same vertex and you still have the same axis of symmetry. So here's the answer you need to write in words. Both graphs open up, obviously, because A is positive, and they have the same vertex 0, 0, and the same axis of symmetry, x equals 0, but the graph h of x is wider because it's a vertical shrink by a factor of the 1/2. And here is where I got the 1/2. Okay, so if it was less than 1, it's going to be wider. Okay, so all of this would be an answer on your homework assignment. Okay, now we just have one more thing, is if x was less than 0, okay, so pretty much if it's negative, it's going to open downward, okay, and that is a reflection in the x-axis. Okay, and again, the same rules apply, wider, narrower, all that stuff. But if A is negative, you just need to remember that it's going to be upside down. Okay, so this is our last one. So here's our function s of x is negative x squared. Okay, so notice our A is a -1, and then we're going to compare it to its parent function. So, same table of values. Okay, and then we're going to plot our points. So I'll show you how to do the values over here. Be careful. So the negative's already there, but then you're going to plug in another negative. So the inside would be a 4, but this negative would essentially just make it -4. 0 obviously is still going to be 0. Let's do -1. And this becomes 1, the negative out front, and obviously by symmetry, those would be the same. Okay, now I kind of jumped ahead. I already plotted my points, and I already drew my curve. So again, notice the symmetry, and notice that it's opening downward. Okay, so let's compare this to its parent function. So the parent function, obviously, is right here. Okay, that's not changing, and these are the same values from before. Okay, here's our function that you just found the table of values for. Notice it opens downward. Now let's actually talk about it. Well, let's see here. Vertex, same. Axis of symmetry, still the same, but the only difference is it's flipped. So here's what you would write in words. Both graphs have the same vertex, 0, 0, same axis of symmetry. However, the graph S of x is a reflection in the x-axis of the graph. Okay, so it's very, very easy. And your homework is a worksheet. Take care, guys.